Right. What data is and the types of data we have available. We said data is a collection of the responses to several variables. So depending on the type of variable at hand, the data may be qualitative or quantitative. Okay, because we have two main types of variables, which are qualitative and quantitative what data. Okay, and we also did mention that quantitative data is made up of two main types. Just a minute. Okay. Yeah, we also touch on the various charts that can be used in data. We talked about tabular presentation, pie chart, histograms, frequency polygon, cumulative frequency polygon, and so on and so forth. Okay, I just did a slide demonstration how you can use a given group data to plot a pie chart. Okay, so that you can find, if you're looking for relative frequency, it is given by the frequency, okay, of the class. So for example, to get this relative frequency, this is given by 23, which is the frequency of this class, okay, over the total frequency. That's summation of all the frequencies here, down here. So summation of all the frequencies down here, which is 177. Okay, and it's usually expressed in percentage. So you multiply by what? 100%. Okay, so that will give you 12.99 over here, right? And because we are expressing all of them in percentage, by the time you finish calculating your relative frequencies, you sum. When you sum, the total should be equal to 100%. Okay. Then we said to plot a pie chart, we can also plot it in terms of the sector angles. So if you want to find the sector angles, that will be expressed in terms of 360 degrees. Okay. So for example, if you're looking for the sector angle for an Indian, okay, an Indian student, that is going to be this frequency, okay, which is 35 over the total, which is 177 times 360, okay? So that should give you, when you do that calculation, that should give you 71. That will be 71, okay, points, 71.19, okay, degrees, okay, as shown here. Then you can use that, these angles, sector angles, to plot what? The pie chart, okay? So that's another way of doing that. In fact, that's the conventional way of what? Plotting our pie chart. Good. Then what else did we say in class? We looked at describing data, and we said there are three key ways to describe data as engineers. We want to look at the shape of the data distribution. We also want to look at the measures of central tendency, okay, which is also central location. And we want to also talk about variation in what in the data, okay? And when we talk about measures of, let me say, yes, I think we looked at the measures of central and first, okay? And we talked about the arithmetic mean, or the average mean also means the average, or sometimes we say the expected value. So the mean of the process, the median, and the mode. And I recall very much we looked at how to find the mean, okay, for ungroup data. So for example, if we're given this data set here, which is ungrouped, okay, so 3, 6, 7, 2, 4, 5, and 8. And you asked to find the mean. Okay, the formula is just to sum. This sigma here means to sum everything. When we say sum means total, okay? So total of, and your X represents the data you have collected or observed, okay? So this says sum your data, then divide by the number of what? Data given. So if we are summing, that will be 3 plus 6. That is, this calculation is down here. So 3 plus 6 plus 7 plus 2 plus 4 plus 5 plus 8 over how many data do we have? 1, 2, 3, 4, 5, 6, 7. Okay, so that n will be 7. So that will be this over 7. And that should give us 35 over 7. And when we do that calculation, we find that the mean of the data is equal to what? It's equal to 5. Okay, that's good. Now, moving on, we also looked at the mean for group data sets. Yeah, so group data sets, we said the key thing we should take note is, in this case, our X is class midpoint. Okay, for group data set, it's going to be the class midpoint. Okay, good. So we'll look at an example, and the formula for that is summation f times x. The frequency is your f, okay, and your midpoints are your x, okay. Good. So you multiply your frequency, each frequency with its what? Corresponding midpoint. So you create another column like this, fx, okay, and then which means you are going to multiply x times f1, okay, x2 times f2, etc. Okay. So we do that multiplication till we get to xk, okay, fk, and we sum everything up. That is what the formula is asking us to find. Meanwhile, the denominator will be, you sum, we'll sum the frequencies here, okay. This means sum the frequencies, okay, total all the frequencies. So you add the frequencies to get the denominator. Whereas for the numerator, you're going to sum everything here, which is the summation of fx to get our numerator, okay? Good. So let's look at an example, a recap example we looked at in class. Okay. So, sorry, yes. So this is the example we looked at in class. We're given the class and the classes and the frequencies. And we said to do the calculation with first the midpoints, okay? So, and the midpoint is just by adding the 2 limit and dividing by 2, okay? So if you want the first midpoint, it is given as what? Let me write it by it. So that will be 34, okay, 34 plus what? 43 plus 43. okay, over 2. Okay, and when you do that, it should give you 38.5, as we can see here. Okay, so you do same for the next one will be 44 plus 53 divided by 2 give 8.5. Okay, 54 plus 53 divided by 2 will give you 58.5. Okay, good. Now, after you've obtained your class midpoint, which is your x, like I explained earlier, you should, just a moment, please. Yeah, so after we've obtained our midpoint, we are to create another column, which will be f times x, okay? So we're going to multiply each f with the x. So this times this, okay, will give us 77. This times this will give us 242.5. This times this should give us 702. This times this should give us what? 122, 1233, okay? And then this times this should give us 785. Okay, good. And like we said, as we are done, we'll sum all frequencies up. So that will be 2 plus 5 plus 12 plus 18 plus 10 plus 2 plus 1 should give us 50, which is summation of the frequencies, the denominator, okay? Then when we are done, we also sum the fx, okay, up, and that should give us summation of fx, that's the total of fx, okay, is 3315. Okay, then we set the mean, which is mu, for those of you who were not in class, is what? Summation of fx, this summation of fx, which is this total here, that is 3315 over summation of f, which is what? 50, and that gives us an answer of 66.3, and which is approximately equals, so we approximate that to the nearest whole number, which is 66. Okay, so having said this, we quickly want to move on to the next thing we did in class last week. Yeah, we also looked at the median. We said the median is the middle number. Okay, it is midway between what? The observations, which means 50% of our data lies halfway, okay, below the median, and then 50% above the median. Okay, and we also did mention in relation to the quartiles that the median is the second quartile, okay? And we did say that for quartiles means divide into 4. So if you have observation, you're dividing into 4, you need 3 partitions, okay? And these 3 partitions automatically means that this second one, which is the second quartile written as Q2, okay, divides the data into what? 50% up here. So 50% of the data, just a minute. Yeah, so 50% of your data lies below, okay, between this and the lowest observation here. And then the other 50% also lies above the second quartile, which is your median. Okay, so we have Q2 is your median, and then we have Q1, which is the first quartile, and Q3, which is the third quartile. Okay, good. So we looked at the calculation of the median. okay, in the context of the general formula for finding out, because we said the median is a second quartile, which means it's a quartile, and we can make use of general formula for finding quartile. Okay. Okay, so moving on, we looked at an example, or better still, for the sake of those who are not in, let's just refresh our memories. So we did say that there are 3 steps involved in finding the median. Okay, the first step is to arrange your data in ascending order. Second step is to locate the position of the quartile or of the median using what? The general formula, which is R divided by 4 over into bracket n plus 1. So after you found the position, you go and locate the data or the observation in that position, okay, to obtain your median. Yeah, so let's take an example in relation to that. Yeah, so we have the very first data. I think we looked at the second data first. Let's look at this. So let's take the second one first, okay, as we did in class. So we have 3, 4, 7, 5, 8, 9, 10, 11, 12. So what you do first in step 1, you are going to arrange the data, which is 2, 3, okay, 4, 5. Then we move on to 7, 8, 9, 10, 11, okay, and what? And 12. So that is step 1, okay? So let's put that as 1. Now, what is step 2? Step 2 is to look for the median position, okay? Good. So step 2 is position. We're going to look for the position of the median, okay? And the position of Q2 is simply given as, we said R over 4, right? But because your median is the second quartile, quartiles are written as QR, okay? Good. Median is Q2. So R, comparing these two means R equals to 2. Okay, so your formula is R over 4 into bracket n plus 1. Okay, good. But our R is 2, so that gives us 2 over 4. Okay, times R is what? Our observations is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our data is 10 plus 1, which brings it to 11. Okay, so this gives us 11 divided by 2. That 2 goes into 4, 2, right? So 11 over 2 is going to be 5.5. So don't forget this is position, okay? So 5.5 position. Okay, good. So in that case, we'll move on to the third step, which is to find the median itself. Okay, and to get the median, which is step 3, we said it is generally the median, okay, will be given. So if you're looking at it from the perspective of the position, okay, it will be, let me just squeeze that here before I write a step 3. We're saying that it's the 5.5 position. So that would be the 5th position, okay, plus a half of what? A half of the 6th and the 5th. That's what we are talking about. So a half of the fifth and the sixth, okay? So halfway between the sixth and the fifth position. So we'll first have to look for the fifth position. So this is first, one, second, third, fourth, fifth, okay? So the fifth position is what? Is 7. And then a half of the sixth position is what? 8, okay? Up here. So that is 8 minus what? Minus what? 7, okay? 8 minus 7 is 1, times half is half. So the final answer is going to be what? 7.5, okay? So 7 plus a half is just 7.5, which is 7.5, okay? So the median is what? 7.5. So this is how we found the median in what? In class. And once you follow this step, you're okay, and you surely get your answer. So this was the second example. In this case, this 2 was misplaced. It should have been here, so that should have been the first 2 here. Okay, so in the same way, you follow the same procedure. Your n is 27, okay? So when we did a calculation, which is 2/4, the median 2/4 plus 27 plus 1, which is 28, okay? Good. This goes here 2. So 28 divided by 2 is 14th position, okay? Good. So we'll just go and look for the 14th position. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th observation is what? Is 5. Okay. So moving on. Good. So the next thing we talked about was how to find the range, the interquartile range, their usefulness, and also how to find the variance, the standard deviation, and the coefficient of variation. And the first thing we talked about, it was in relation to the range. Okay, we looked at the range first. And we said the range is just the, okay, it looks at the coverage of the data. So if you have your smallest observation, let's say the data is 2 and the largest observation is about, okay, then it's just telling you that between, let's look at it in terms of maybe numbers, okay? Good. So if we're looking at the range, we can have maybe 2 Ghana cedi and 120,200 Ghana cedi. So let's say these are salaries of maybe workers, or I mean, yeah, some kind of money given to people. Then your range just gives you coverage, okay, of the gap between the lowest percent and the highest observation, okay? It tells you how spread the data is, or what is the gap between the lowest and the highest figure, okay? Good. And the value or the formula is just the maximum observation minus the minimum observation. Good. Now, moving on, we also talked about the measures of that's interquartile range. So with the interquartile range, I'm going to go back a bit, and then we'll get the same data we use for the median, okay, to demonstrate that. So let's go back a few slides. and write this data down. So that is 3, 4, 7, 5, 8, 9, 10, 2, and what? And 12. Okay, so we're going to use this data to demonstrate, okay, the computation for interquartile range. Good. So in this case, we have, or better still, let me use, okay, let's still use the same page. Just a minute, we need a fresh page. Okay, so I'm sure you can see my screen displayed a whiteboard. Yeah, so let me select a sequence of points, maybe 2, 3. Okay, we have 4, say 5, 7, let's say 8, 9. Sorry, 8. Let me put 9 here. Then let's have 11 and say 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's add one more. Let's say another 2. Okay. Good. So if this is our data, then we said in step 1, we need to arrange the data in ascending order. Okay, so that should be, we have 2 2s here, so we'll have 2, 2, 3, 4, 5, 6. No, we don't have 6, so we have 7. We have 8, 9. So 8, 9, 11, and finally 12. Good. Step 2, we need to find a quartile position, okay? And like I explained earlier, the have 3 quartiles. The first quartile, Q1, Q2, and Q3. This is your minimum observation. This is your maximum observation. Okay, good. So, and the general formula, we said we always use QR. So QR, the position of the quartile position, okay, is giving us R/4. Okay, to bracket what? N plus 1. Okay, so interquartile range is simply given by, let me put that formula down. So the interquartile range, the IQR, okay, is given as the third quartile, okay, minus the first quartile, which gives a measure of what is happening in the central 50% of your data, okay? Good. So it means we need to find Q3 and we need to also find Q1. Okay, so we'll, in our next step, we're going to look for Q3 and Q1, which means step 2, we have to find position of, sorry. So we're going to look at the position. Let's find position for Q1 first. followed by that for Q3. So position for Q will be R is 1 here, right? Good. So that will be 1/4. 1/4 into bracket. We have 10. Our data set is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 plus 1, okay, which will be 11/4, okay. So 11/4, okay, that will be 2/3/4, which is 2 point.
Sir, please, sir.
Yes. Yes, I'm listening.
Sir,
Yes, go ahead.
Sir, please, they give me data. The giving data was 11. So it is nothing.
I'm full of
So this time we are not looking for the median. We are looking for
interquartile.
Q1 to find the interquartile range.
Okay.
That is the difference. So, okay, so moving on. We have the position for Q1, which we were finding A to be 2.7 feet. Forget, this is position. It is not the first quartile, okay? So we have to go on to step 3 to look for the quartile itself, which is the first quartile. So we said it is 2.75, okay? So by conversion, this means that the second position, okay, plus 0.75, okay, distance between what? Third and the what? And the second. So third minus second position. This is what it means, okay? So which means that if we're interpreting this one using the observations, then the second data here, array data here is 2. This is the second data, which is 2. Oh, sorry, let me put Q1 first. So Q1 will be equal to what? The second data, which is 2 plus 0.75, okay, into bracket. What is the third data here? The third data is what? 3, okay, minus the second data, which is 2. Please take note. This looks very much like this, but here we are looking at it in terms of position, trying to understand the value here, the 2.75, okay, in terms of position, right? But here we are making use of the numbers from the observation, or we are making use of the actual observed data in that position. Okay, good. So the fact that they look the same does not mean it's the same. Take note of that. Okay, so this will give us, let me clean this formula from the, so this will give us 2 plus 3 minus 2 is 1. 1 plus 0.75 is 0.75. So plus 0.75 will still be what? 2.75. So our first quartile is 2.75. Now let's go look for the third quartile. So we want to find the third quartile as well, which is Q3, okay, to enable us to find the interquartile range. So for Q3, we already have step 1, data has range. So we'll go to step 2, which is looking for the position. So position of Q3 for position of Q3, R is what? 3. Okay, so that will be 3 over 4. 3 over 4 into bracket 10 plus 1. Okay, which should give us so that will be 30 divided by 4 should be that will be 7.5. Okay, 7.5. That's 28 2 over 4, right? No, sorry, we are dealing with
Sir, please, is it 33 divided by 4 or
yeah,
30
33
divided by 4?
divided by 4. So 33 divided by 4 will be 8. Okay,
825.
just a minute. So we have
8.25.
8.25.
8.25. Yeah.
So that is 8.25 position. Okay, so let's interpret this first before we go on to look for the actual value. So this simply means the 8th position, okay, plus 0.25, okay, distance between the 9th and the 8th position. That is what this means, okay? So let's go look for the values to find the actual third quartile.
Sir, please.
So we have Q3 will be the 8th position. There will be 1, 2, 3, 4, 5, 6, 7, 8. So this is our 8th observation, which is 9, plus we have 0.25. Okay, the 9th, this is the 9th position, which is 11. Okay, minus the 8th position, which is 9.
Okay.
So this will give us 9 plus, this is 2, okay? So 2 times 0.25 will give us 0.5. And then 9 plus 0.5 will be 9.5. Okay, as our answer. So we have our answer for the third quarter, 9.5. Then we can find our interquartile range. So our IQR so IQR, okay, which is given by our Q3 minus Q1, okay, is equal to 9.5 minus 2.75. And what we do that calculation, we should get 6.75. Okay, 6. Can you just check that for me?
So it's correct.
Very good. Okay, so that is how we get the interquartile range as well. And at this juncture, I'll take 1 or 2 questions if there are any. Okay. The next thing we talked about was the measures of variation. And we looked at what the the variance means and what a standard deviation means. Okay, we said that the variance is just a variation from the mean, the expected value, okay, of the data. So then we look at the estimation. Yeah, we said the notation of the variance is sigma squared. This is it, okay? We write as sigma squared. Okay, good. And we also have, so we call this the variance. Okay, then we also have what we call a standard deviation. So the standard deviation is the sigma. So what variance is sigma square, standard deviation is sigma. Okay, good. So in very simple terms, what it means is we can either find a variance first and find the square root to get the standard deviation, or we can find a standard deviation and square it to get a variance. That is what it simply means. Good. So let's go back to the example we solved in class. So we did say that to estimate the standard deviation, okay, you find there's a formula, summation, okay, of your data minus the mean. So what it means is if I give you data, first find the mean, okay, which is summation of your data over n, find the mean. Then when you finish, you create just create a table of values with your x. So the data are given to you. So if it's in the case of the data we just looked at, you have 2, 2, 3, 4, etc., right? And then you use the mean of the data, which is x minus the mean. When you find the mean, you come and subtract the mean from each of these values. Okay. And after that, you square the results you have here. Okay. So x minus mu square. Square everything. Okay. That gives you the term. Then as for summation, I think we know what it means. So after you've done this quantity, then the summation comes. Summation means total everything. So you total them, you sum, okay, across the rows to get the total, which is summation x minus mu, okay, squared, right? Then that will give you our numerator here, okay? And then divide by the number of observation, which in the case was 10, okay? And once you are done, you find the square root of the resultant to give you the standard deviation. So let's try an example. Okay. We want to, let me clear the screen. Yeah, so these steps are demonstrated, okay, as we can see here. So let's try an example. We have the data 20, 30, 40, 50. Okay, and like I said, the first step is to find the mean of the data. So the mean will be to sum the data up, which will be 20 plus 30 plus 40.
The answer is 200.
Yes, I know. Plus 40 plus 50 plus 60. Okay, all over what? All over 5. Okay, that is the mean. So once you do this calculation, you should get 200 over 5, which will give you the mean as what? As 40. Okay, good. Then once you are done, like I said, you create a table with X and then X minus the mean. Okay, so you bring the same data here. That is why we have 20, 30, 40, 50, 60 here. Then you come and do this calculation, X minus the mean. So that will be 20, okay, 20 minus the mean of 40. So 20 minus 40 will give you what? Negative 20. Then 30 minus 40 will give us 10. 40 minus 40 will be 0. 50 minus 40 will be what? 10. And then 60 minus 40 will be 20. So that is how we get this dispersion, okay, or deviation from the mean. And after that, we are going to square these values. So this is also obtained using what? We're just squaring the values here. We square them. So that will be minus 20 squared, negative 10 squared, squared, 10 squared, and 20 what? 20 squared. Okay. So you will notice that 20 squared will be 400, 10 squared 100, 0 squared is 0, 10 squared 100, 20 squared is 400. Then, like we said, you have to find the summation, because the formula says summation of what? The square deviates. Okay, so we're going to sum everything up, which will be 400 plus 100 is 500, plus 0 is 500, plus 10, 100 is 600, plus 400 is 1000. Okay, so the summation will be 1000. And we saw from the formula that the standard deviation is what? Is the square root of the sum of deviates, sum of square deviates, sorry, sum of square deviates, okay, from the mean, okay, divided by n. Okay, and this time we found the sum of square deviates, which is this total here. This is summation x, okay, minus mu square, right? Good. So in that case, we're just going to put it into the formula for the standard deviation and then find the actual value of the standard deviation. So this will give us sigma is equal to square root of sum of square deviates is what? 1000 over our n. The n is the number of observation. We had 1, 2, 3, 4, 5. Okay, so 5. So this will be square root of 1000 divided by 5. 5 goes here 2. So it means we have 200. And the square root of 200 should give us, yes, so that is for you to calculate for me. So square root of 200, what are we getting?
14.142.
14.14. So approximately this gives us 14 for our variance. Okay. So that is how we get, sorry, for our standard deviation. So that is how we get the standard deviation for our data. Okay. And like I said, the variance is The variance is just the square, okay,
The screen is blaring.
of the standard deviation. So if we want variance, variance means square this one, just square it, okay? So that will be your 14. Please don't go and square the approximated value. So that will be 14.14 squared, okay? So you square it, and then you come back to the truth, okay, which you earlier had. You see, it was square root of 200. That gave you 14.14. So when I square this, I should go back to what? 200. So the variance of this observation is 200, whilst the standard deviation is 14. If there are any questions, you can ask. If there are any questions, you can ask. Okay. Yeah. If there are no questions, then move on. So let's try. Okay, we still have enough time to look for group data. So let's try finding the variance. We want to find the variance, okay, and the standard deviation, okay, for the given data set. So let's have 5, 6, let's have 7, 2, 3, then we have, let's say 8, and let's have another 8, and say 10, okay? So find the variance and the standard deviation for this ungroup data. I'm giving you some 5 minutes to do that for me. So,
Sir, I had a variance 6 point.
yeah, that's
6.12.
okay. So let me work with one person. I'll work with one person.
Sir, I'm here.
Very well. So what we need first is a table with X, which will be 5, 6, 7, 2, 3, 8, and 10. Then we need another column X minus. Okay, so here you give me the values you obtained. 5 minus 6.125 will be minus 1 point what?
125.
Then the next one will be 0.125. The next one
So it's negative.
yes, thank you. The next one
Sir, please, before you proceed,
yes.
I think for the X values, I didn't repeat the 8.
I be that one there. You've counted it already. So
No, you have to repeat it.
I used the same number of events to calculate for the mu, but then I didn't repeat it when I was calculating for the X minus mu.
You have to. It has to be.
Oh,
that.
okay.
Sure.
Okay.
So 7 minus 6.125 will give us 8.
That will give us 0.8. 75.
The next one is 2 minus that will give us what? This will be
Negative 4.125.
4.125. The next one will be negative 3.125.
Negative 3.125.
Negative 2.125.
So this is big. So
1.875.
1.875.
And it's the same thing to the other one.
1.875.
3.875.
87.
Oh,
Okay, then we're going to score them. Okay. So when we square, so when we square,
So this one with the decimals is menu.
yeah, so I'm working
Sure, so me around it to two decimal places.
yes, because of the feedback, I'm working with where is Deborah? Yes. So
Yes, sir.
Deborah, I've unmuted you. I think and Ibrahim Nayat. So I've unmuted you as well. Ibrahim Nayat. Good. I've unmuted you as well. So you can unmute yourself and
Yes, sir.
yes, when you
Yes,
see
sir.
what you have.
So the 1.27.
1.27.
7, yes.
Okay.
The 6 is 0.12.
0.12.
12. The 6 is 0.0.
What do we have?
The 7 is 0.77.
0.77. Next one.
Then the 2 is 17.02.
17.02.
0.02. Yes.
One is
The 3 is 9.77.
9.77.
Yes. So it's 17 or 14.
17.0.
Yes. Yes, sir.
Okay. Next one.
The 8 is 3.52.
3.52. Okay. Next one.
The same thing, 3.
3.52.
And the 10 is 15.02.
15.02.
0.02.
Okay. Very good. So then the next stage is to sum everything up. So we're going to sum everything. What do we have?
50.99.
So 50.99.
0.99.
Okay. So we have our formula. So take note, variance is summation f minus square over n. But standard deviation is the square root of what you have up here. Summation x mu square. Okay. So this is simply going to be that. Let's start with the variance. This is a summation. So 50.99 over our observations 1, 2, 3, 4, 5, 6, 7, 8 over 8. And this will be the square root of 50.99 over 8. Okay, so when we do that calculation, what do we get? 50.99 over 8 divide, yeah, will give us what?
6.37.
6.37. And this will be the square root of the variance, the square root of 6.37,
3 is 6.3.
which will give us
2.52.
2.52. That is how we get our standard deviation and our variance, okay, for so now let me give Enki Nathaniel, you can come in with questions.
Sir,
That correction has been made. The computation here is 0.02 instead of 0.12. So which is reflected here as 50.89. Okay, well done. So now let's move on to our very last example, which is for the grouped data set. Yeah. For group data, our formula for finding the standard deviation is the square root of summation fx squared over n minus the square of summation fx over n. Okay, there's a huge difference here. The second term here says that sum, or first of all multiply f, the frequency, with the midpoint, then sum it up, then divide the resultant with n, the number of observation, and once you are done, square the resultant. Okay, good. Whilst the left term here says that square x before you multiply f with the square of x, then total and divide by n. They are two different things altogether. Okay, good. And in the case of the standard deviation, once you're done, you find the square root to get your standard deviation. Now let's take an example to demonstrate what we just talked about. Yeah, so we have a previous example. Like I said, you will not be given the class midpoint. Okay, the table will only consist of the class and the frequency. So what you need to do is to find the midpoint, okay, as the first step in your computation. So once you're given the class, okay, as a class interval, you find the midpoint by adding the two limits, which is 34 plus 43 divided by 2 to get a midpoint. Then after that, we know from our formula that we need summation. The first term says square x, okay, and multiply with f. So you need more or less, let me say, a column for x squared first. Good. Then after that, you need a column for f times x squared here. Okay, over n. So I'm going back to the formula. Minus what? Summation of f times x over n all squared. So it means that we need also another column for what? F times x. Okay, so we need a column for x squared, we need a column for f times x squared, and we need a column for f times x. Okay, good. And that will give us sigma squared is equal to what we have over here. Okay. So in our computation here, we have F, we also have X. So what you can first create is, you can find your X squared. Okay, 38.5 gives you what? Just create the thing properly for it. So I want you to help me with the computations for that column. So we want to create an X square column in here. So 38.5 square. I'm unmuting Deborah. So Deborah, I've unmuted you. And I also have Ibrahim Najat. I've unmuted you. Abdullah, I've unmuted you. Let's work. So X squared gives us what?
The X squared 2 will give you 4.
No, X squared, not F. 38.5
I
squared.
will take X squared, sorry.
Sir, the number is huge though.
Yes, sir.
1482.25.
0.25.
1482.25.
0.25.
Yes. Good. Next one.
2352.25.
2352.25. Okay, next one.
3422.25.
3422.25.
342. 322.25.
Yes, sir. 0.25.
Next one.
4692.25.
4692.25.
92.25.
Next one.
6162.25.
6162.25. Next one.
7832.25. 32.25.
7832.25. Then the next one will be
9702.25.
9702.25.
Yes.
So those give us the X squared. Then now look at the very difference. This term here is F times X squared, the frequency times X squared. So we are going to multiply the frequency and the X squared, okay, to give us this column here. So we'll pick the frequency, which is 2. Let me change my marker. So we'll pick the frequency, which is 2, and multiply it with X squared. So when you do that, that should give us this value here. So check that. 2 times 1482.25.
Yes, sir.
Yes. Then you do same for the next one, which is 5 times 2352.25 should give us what you have here. Then the next one will be 12
Yes.
Yes, sir.
times 3422.25 should give you this. Then 18 times this should give us that. Okay, 10 times this should give this. Then we have 2 times this should give us that. And then finally we have 1 times this should give us this. So that is how you get your f times x squared. Then finally, we also have f times x itself. Okay, so we are going to look at f times x. So we are going to do this computation f times x. Okay, so f times x. Let me clean the other arrows. Okay, so we have f times x coming here. So this computation will be 38.5 times 2. Okay,
77.
77. And 48.5 times 5.
2
for 2.5.
242.5. Then
Yes.
58.5 times 12.
702.
702. Then 68.5 times 18.
1233.
1233.
1233. Okay, then 78.5 times 10.
785.
785. Then we have 88.5 times 2.
177.
177,
77.
as we can see here. Then 98.5 times 1. 98.5.
98.5.
Okay, so once we are done, the next stage will be to sum fx and also to sum fx squared, okay, for our computations. Now, our computations, okay, the summation of fx squared is what we see here, which is 227242.5. And the summation of fx was 3315. Okay, whereas the summation of our observations, let me go back a bit. Let's go back a bit. So we have the yeah, so here we are looking at the summation of your frequency, okay, summation f. So 2 plus 5, which is 7, plus 12, which is what, 19, plus 18, which is what, 37, okay, plus 10, which is 47, plus 2, which is 49, plus 1, which is 50. Okay, good. So your n here is 50. So that gives us the n you are finding here, which is actually summation what, f. Okay, and then in this case too, this is also summation what, summation f. Okay, good. So once you put that into the formula and you do the calculation, and be careful when you are doing the computation also at this point, okay, don't be in a rush, just take your time. So that should be 331.15 divided by 50, calculate it, and then square. Then this divided by 50, also calculate that. After that, try and simplify the terms under the square root, okay, before you find the square root. So do the calculation under the square root for me, because that will give us the variance. So the variance is just that under the square root. which is summation of x squared over our n minus summation f x, okay, over n all squared, which gives us 227,242.5 over 50 minus 3315 over 50, okay, square. Okay, so what do we have for our variance? I would prefer 3315 divided by 50 gives us what? Yes, so let me. Yeah, so Deborah. Yes, Deborah.
So the answer is 66.3. That's for the 3315.
66.3. Okay, square.
And yeah,
This
and the
side.
square root.
This side.
67.41.
Are you sure? 227242.5 divided by 50. I'm not sure you get
0.3. Hello, sir.
yes. Yes, I'm listening, Deborah. I think you get 4, 5, 4, 4.
4544.85.
4548.41.
Okay, minus this. So then you do the computation for this two. This will give us
Say 149.16.
1496 point what?
0.16, yes.
Point what?
16.
Good. So once we calculate that, this is the answer we are getting. I want you to confirm that. Class, confirm that for me.
Yes,
Yes, it's
that's
correct.
correct.
We're getting the same answer. Okay. So which means that then our standard deviation is just the square root of 1496.16, which
Sir,
should give us, yes,
I'm getting 149.16.
149.
Yes, sir.
149.16.
0.16.
Okay, so this is
Sir,
1.16.
you get
And once we find the square root of that, that should
you
give
get
us 12,
38.
12.21. Please cross-check your answers again. Very important. Okay. So cross-check all results which you are
So you
getting.
get 12.213.
Yes. So this is approximately 12 books. Okay. So you are right. 12.21 to 2 decimal places, approximately 12 books. Okay, very well. So that is how we get the standard deviation and the variance for group data. Okay, so at this juncture, I'll take one or two questions, if any, before we wrap up for today. Our time is already far spent. If there are any questions, you want to bring them up. Okay. So in the absence of any other questions, you see on the slides, you have some exercises for you to also try. Okay, so try them. I'm going to post your first assignment on the LMS for you. Okay, so do check from LMS. Okay, and then respond accordingly. This time there wouldn't be an extended deadline for assignments. So take note of the dates and make sure you submit your assignments, okay, on time. Good. Thank you all for coming today. See you in the next class. Bye-bye.